interested in functions where the domain is the natural numbers. Here, two-line notation is no good, but describing the function algebraically is often impossible. Even tables are a little awkward since they do not describe the function completely. For example, consider the function described by this table. We're going to be working from the natural numbers to the natural numbers. And we're going to find the function with this table here. 0, 1, 2, 3, 4, 5. As 0, the outputs are going to be 0, 1, 4, 9, 16, 25. And then so on. Okay, have I given you enough entries for you to be able to determine f of 6? What's the output that I get when I plug in 6? Now, you might guess that f of 6 is 36 because this looks like we're taking all the inputs and squaring them. So if I plug in 6, I should get 6 squared, which is 36. But there is no way for you to know this is for sure. Maybe I'm being a jerk and intended that f of 6 equals 42. In fact, for every natural number n, there is a function that agrees with the table above, but for which f of 6 equals n. Okay, suppose I really did mean for f of 6 to equal 36, and in fact, for the rule that you think is governing the function to actually be the rule, then I should say what that rule is, f of n equals n squared. Now, there is no confusion possible. Given an explicit formula that calculates the image of any element in the domain is a great way to describe a function. We will say that these explicit rules are closed formulas for the function. There is another very useful way to describe functions whose domain is the natural numbers that relies specifically on the structure of the natural numbers. We can define a function recursively, which we will discuss in the next video. I'll see you then.